Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
All right. Hey, Google developers. Welcome to the Michael and Ryan Show. I'm Michael Manoochehri.
And I'm Ryan Boyd.
And we're here to talk about some new features of Google BigQuery, as well as answer some of your questions. So if you have some questions for us, visit us at our Google Developers Live page. That's developers.google.com/live, and leave your question on the moderator link below.
And if you're seeing a recording of this later, you can feel free to ask your questions on Stack Overflow. Michael was just answering some questions here quickly.
As I always am.
As we were preparing. So
use the Google-BigQuery tag for that. Great. So if you've been following our recent Google BigQuery blog posts, you know the theme for this week is making BigQuery more flexible. So today we're going to start by talking about some new features that we've just recently launched to help make BigQuery more flexible. The first is the batch processing for BigQuery, which allows a more flexible pricing model for your queries. And the second is the Google BigQuery connector for Excel, which will allow you to use it in more flexible environments such as spreadsheets. So we'll talk about that later. So let's talk about the batch processing for Google BigQuery. Google BigQuery is great for interactive queries, queries over large data sets that return very fast. We found some customers using Google BigQuery for batch processing as well. So queries run overnight, queries that cache data for later use, where interactivity is not the main goal. So we've introduced a new feature for this use case at a much reduced price, which is Google BigQuery batch processing. This allows you to set the priority of a query to a batch mode, which allows the query to run later. So the query will be run somewhere between 30 minutes and 3 hours after you actually insert the query at a much reduced cost. This is great for applications that have a data set and allows you to run queries either interactively or in a batch mode, letting you build much better applications for this kind of use case.
Yeah, it's really easy to do. It's a simple new property in your JSON configuration. You just specify the priority mode as batch, and our client libraries already support this as well. So try it out. And I wanted to actually stop over to our computer here and show you an example of a dashboard. This is the Beam dashboard, which shows some retail statistics. And this is the type of thing that you might want to have some of the queries running in batch mode, while other of the queries run in sort of an interactive manner. So this is a dashboard showing the retail statistics, sales from a retail outlet, and a lot of different graphs here going over, what do we have, like 500,000 rows. Whoops, sorry for that. But going over a large number of rows here, but overall, 500 million rows. And we have profit and discount per category, top products per category, profit in various ways. So these types of things you might be able to calculate on a nightly basis in this batch mode. Whereas, maybe if you want to allow users to drill down on certain bits of data, for instance, the sales just over the last week or something like that, you might want to have that running more live against the live data set and allow people to drill down into particular categories or drill down into particular types of products and things like that. So this is one of those use cases where you might want some things in batch and really caching those query results, and then other things you want to perform live.
And on the flip side, it's easy to make an application that's actually doing more batch queries, and when you need that interactive query immediately for a presentation or for some kind of analysis, you can run them when you need them. So it really expands the type of applications you can build with Google BigQuery.
Exactly. Now, I'm going to start talking a little bit about the other feature that we launched, which is the Google BigQuery connector for Excel. The BigQuery connector for Excel is basically a tool which allows you to, let me hop over to it here. It allows you to basically pull in your data into Excel from BigQuery. So you can run queries off of hundreds of millions or billions of rows of data and pull your aggregate results down into Excel for further analysis. And this is very useful if you're spending a lot of your time running data in Excel. We actually have had a feature for a while now which allows you to do this type of thing with Google Spreadsheets, with Google Apps Script and Google Spreadsheets. And I'll show you that here quickly before we dive too much into the Excel version. This is a dashboard I built using Google Spreadsheets and Google Apps Script that basically I can hit here, I can run the query, it dumps the results in from BigQuery, and then does a graph right here within Google Spreadsheets. Well, we wanted to bring the same capability to Excel users, and we've done that with this BigQuery connector. You can find it at bigquery-connector.appspot.com. And essentially what it is a proxy server for your queries. So when you run your queries in Excel, it makes HTTP requests to the BigQuery connector for Excel, and those HTTP requests then get translated into API calls to the BigQuery REST API. But it all happens seamlessly for you as a user. There's just a few setup processes, and it's really simple. So the first thing that you need to do here is actually authorize the connector for Excel. I've already granted OAuth permission here, but if you haven't, you'll just be prompted to approve OAuth request, and then you create this key. And this key is a value that you'll just need to copy and paste into Excel. So we're going to do that here in a second. But the other thing you want to do is download this IQY file. And the IQY file is really just a configuration file that tells Excel the information that it needs in order to query against the BigQuery connector. So we're going to hop over into Excel here a second and show you how some of this stuff is used. So I'm going to actually run a query here. The query is going to be against the U.S. birth statistics data. So all the births since 1969 in the United States. It's, I think, 137 million rows.
It's a pretty big data set.
Yeah, it's pretty big. It's still small by BigQuery standards, but it's a great demonstration data set. So I'm going to run that query, and I've actually templatized that query a little bit in a similar way to what you could do in Excel. And I've put in here additional fields, average mother age, and then I have this full query here. So let's show you how we would run the query. We're going to need a few bits of data for setup, but I'm going to go to the data menu here and say get external data and say run saved query. And then I'm going to select that IQY file that's in my downloads folder. So the IQY file is right here, connector.iqy. I'm going to say get data. And it's going to ask where I want to put the data. And I want to put the data into a new sheet. And I want to set up the parameters that are required to connect to the connector. The parameters are the query itself, which I'm going to get the value from this cell. Then the project ID, and the project ID is also pretty easy to get. We can get that from the BigQuery UI here. So I have the project ID, it comes up in a hover, and I can copy and paste that. And enter in the value in this box here, and then the key is that generated key that we use to pass our authorization over to the BigQuery connector. So I'm going to copy that in. And I'm going to hit OK. And again, we were saying populate the data into the new sheet, run that query. So this query is going to get us the state and year of every birth, but aggregated based off of the average age of the mother when the child was born.
And this is doing a table scan of how many records did you say?
I think it was 137 million.
137 million records.
We'll actually show you running the query in the BigQuery UI here in a second. And you'll see some more data, statistics data. But let's make this a little bit larger for you here. So here's the data, and it's basically every state and the year. And then what the average age of the mother's birth in that state in that year. And so that's really simple. Now, let's just say we wanted to change this, because I actually want the average weight of the babies rather than the average age of the mother. So I'm going to hop over to this first sheet here, and I'm going to change this to say average weight pounds. And you could, of course, get these values, build these values up from a... you can build these values up from a, sorry, it looks like we had a little bit of glitch here with my sharing. So you can build these values up from the from other fields within your Excel spreadsheet. So
using some of the features of your Excel spreadsheet, you can actually incorporate that into the query that you're running now.
Exactly. So I'm going to hop over here, and I need to reshare my presentation window. It looks like we had a little bit of a glitch here, but let me do that.
So while we're doing that, I think it's great that for both of these applications with Google Spreadsheets or Excel, it lets you use what you're used to for analysis with Google BigQuery.
So example, like in there, I built up the formula and I just did a simple replace on the fields that I was trying to substitute in the formula. And that was pretty easy, but you might want to actually do something more complicated where you're using the built-in Excel functions and accepting the analyst input. Because not all analysts will necessarily know how to use SQL.
Right.
But as long as you can set up this initial spreadsheet for them with SQL, it's fairly easy for you to do then. And I'm hoping I can. Yeah, here we go. So I'm going to reshare my screen here.
Right, looks good.
And there we go. I've reshared my screen, and let's hop back over into Excel.
Great.
Sorry about that little glitch here, but so here's my query. So I wanted to modify this to say the average weight in pounds instead of the average mother's age. So I've modified just this field here quickly, and you could specify any of the other fields that are part of the table. But I modified that, and then I'm just going to go over to the data tab here and just say refresh. And if we hop over to our sheet, we can see we had the average age of the mother's age when they gave birth, broken down by year and state. And when this refreshes here, we're going to actually get the instead of the mother's age, we're going to get the birth weight. So we'll see here, and it's a little small again for you, so enlarge it. And let's see here. So we can see that refreshed it in really easy. All I had to do is press one button to refresh that information. That was very simple. If you're actually using the Windows version of Excel, you can actually set up dependent fields. So you can basically say if the fields that were used to build up the query change at all, you can ask it to automatically refresh. So there's none of that manual
That was
refreshing.
the same data set, the same original 100 and something million record data set.
Yes.
You just changed one parameter and rerun the query.
Exactly, and it was really easy for us to do. But we can run this type of query directly in the BigQuery UI, right? Just getting this data, and you can see I ran it over here. Took about 7 seconds, processed 2.5 gigabytes of data. So that was pretty simple to run within the BigQuery UI. But the advantage of Excel is the analysis that you can do after you run the query. So let's say that I want to take this data and I want to go over and do a pivot table. So I just say pivot table, and it creates the pivot table here. And then what I can do is, this is just the count to start with. Let's just change this to be the average instead of the count. And so now we can see here for every single state this massive table that shows you what the weight of the babies were in that state broken down by year. But if we want to take this from a pivot table and take it into a chart might be more easy for some people to read, although I don't want to chart out every state. So let's limit here to just pick a few states. So we'll pick California, Colorado, Alaska. Let's pick Alaska.
Sounds pretty good.
And so just a few states here, and I don't know, Louisiana, and we'll pick a few states here, and now we're going to take this and make it into a graph. So I have that data, and now let's take here, and we'll just say charts, and we'll say a line chart. And it looks like I actually selected a value here, so that didn't quite work out. So let me actually use that. So let me recreate create this here without me having selected a value. So let me just say line chart. Is this going to work?
There it is.
All right, there we go. So here we have our graph, and these are aggregate results, but the source data is over 100 million rows of data. So it's pretty fantastic.
So with very little SQL, or actually no SQL, no SQL command, you've actually been able to pull in all the data from BigQuery into a pivot table and chart it just using what you normally are used to in these spreadsheet tools like Excel.
Yeah, I mean, I did create that initial SQL, but for the analyst, the IT person can create the SQL, and the analyst can just plug in the fields that they're interested in, and it's really easy. And we can then look down and see, hey, we have 7.6 or so pounds per baby in Alaska. But then if we go down and see Colorado, it looks like about 7.1. So,
and you know what I'm about to say? Is
yeah,
that statistically
it's not
significant?
statistically significant.
We don't know.
I don't know. So you can talk to the CDC or talk to Michael if you're trying to figure out whether
export your data and run it in R. You can do all kinds of stuff with
exactly.
this.
Exactly. But so we can see here we're able to really easily pull in data, run huge queries on large data sets in BigQuery, pull the results into Excel, throw them into pivot tables, throw them into graphs. It's a really powerful feature.
Right. I love this idea of using the workflows you're used to and using the power of BigQuery for what it's good at. So great. We'd love to get your feedback on some of these new features. And a great way to get the feedback to us is to join our new Google Cloud Platform Developers Google Plus page. So if you search now for Google Platform Developers and Google Plus, you'll find our page. Please add us to your circles. You can actually, comment on our threads. We post a lot of things that are coming up. For example, some new events that we're going to be at and some upcoming conferences. So let's talk about some of those. So Ryan, can you talk about some of the conferences you've been to or you're going to be at in the near future?
Yeah, I recently just did a conference, or actually a local meetup last weekend on Saturday. It was a great event. Went a lot of the day on Saturday, but it was a big data science meetup, and it was in Fremont, but at the SGI building in Fremont. And it was fantastic. We had 3 separate speakers, and those 3 speakers were myself as well as some folks from Zementis and Pervasive, all talking about some big data technologies, everywhere from kind of predictive modeling to ETL to running queries using a tool like BigQuery. Right. And it was a fantastic event. It's only the meetup's only been going on, I think this is the 6th session of the meetup, but very well organized, and they had over 60 people at the event. So it's great to go to these local meetups. Let us know if you're an organizer. Let us know what types of meetups you're having. Reach out to us. It's possible we may be able to attend. So that's just one of the meetups. But
we'll definitely see that group again.
And yeah, exactly. And coming up, we have a couple other events. So I think next week we have the I believe it's on the 5th, the Google Developer Groups in Silicon Valley. And the Google Developer Group in Silicon Valley is hosting myself to talk about BigQuery and answer questions that you have as developers. Unfortunately, it's turned into a rather popular event, fortunately or unfortunately, however you want to look at it. But so it's fully booked, but get on the wait list and maybe you'll be able to get in. But that should be great. And then after that, the following week, we have the XLDB conference in Stanford, and I'll be speaking there about BigQuery to a group of hardcore scientists. So hopefully I don't disappoint them, but anyway, Michael, I guess we have some other events coming up in the fall, too.
We're excited to say we're both going to be at the upcoming Strata conferences. One is in London at the beginning of October 1st and 2nd, and there's a Strata conference in New York at the end of October. So at Strata London, Ryan's going to be talking about BigQuery, and we're going to have Catherine Brisbane, another one of our teammates, talk about data journalism and data gathering there. So that'll be really exciting. We're also planning on some community events around that time with the London GDG group and some other groups. So follow our Cloud Platform Developers page for more information about that. And I will be speaking at Strata New York along with Catherine. We'll also have a talk about using BigQuery with GitHub data, which is very exciting. Ryan, do you have some community events around that time on the East Coast as well?
Yeah, exactly. So we've worked with some of the community organizers to plan some events over in both Boston and New York.
Great.
So local Google developer groups in Boston and New York, and that should be fantastic as well. So let us know if you have other opportunities for us. We're happy to look at our travel schedule and see if we can fit those in. Sure. But there should be some great events.
We'd love to see you guys there.
So this has been fantastic. I hope you have enjoyed some of our new features that we've been launching in BigQuery. Let's actually jump over. We actually do have some questions over here on our moderator. So if you're trying to get into moderator, you can look at Google Developers Live page, and you can click on our event on the Google Developers Live page if you're not already on that page. And you can see the moderator below. And we have a couple questions here. The top question coming in here is, could you also point out scale-wise where you will use BigQuery versus Google Cloud SQL?
Right.
So we're happy to talk about that. Google Cloud SQL is our MySQL-based solution that runs in the cloud. It's a really simple kind of database offered as a service that you can use from App Engine and maybe even from some other environments.
Right.
But basically, it's a MySQL database. It's a relational database. So from a scale perspective, it's not going to have the same scaling properties as something like BigQuery. So I think let's just give you some basic properties of these different types of databases. Your standard relational databases use indexes to find results quickly. And indexes are fantastic if what you're looking for is available in that index. You can get fairly quick results. But indexes have two properties which aren't so good. And one is that it takes a while to build up the indexes. So as you ingest the data, it takes a while to build those up. But then secondly, if you're trying to do large-scale aggregate data across, in an ad hoc fashion, you don't necessarily know what columns you're trying to query against or what sort of aggregates you're looking for.
Yeah.
And the aggregates oftentimes are kind of impossible to really include in the indexes.
You end up running table scans for some of these things over enormous amounts of tables with lots of links.
Yeah, exactly. So full table scans used to be considered kind of the devil.
Right.
We have this quote from our Google I/O presentations, one of our colleagues, Jordan, who basically said that, a quote from a 16th century French-Italian philosopher or something like that, where he's like, if you're running over a full table scan over hundreds of millions of rows, you're going to have a bad time. And typically that's how it is. But BigQuery actually does full table scans, and it's designed to do full table scans. Pretty much every query you run against BigQuery does a full table scan. But since we can distribute that over, tens, hundreds of machines around the world, those queries can still run really quickly, even though they're doing a full table scan. Each machine is only processing a very small chunk of data, so it allows us to do the full table scans quickly. So, I would say use Google Cloud SQL if you're trying to power your web application for, just sort of let's say you have an online forum or something like that and you want to power that. You need a lot of write capabilities. You need to update data. You need to insert new data, add and delete columns. Cloud SQL will be really good for that. But if you really need to do the performance of sort of large-scale analytics, that's where BigQuery comes in. BigQuery doesn't allow you to modify the data. It allows you to insert new data. But then you can run queries over it much, much faster.
I think of it that way too. I think of Cloud SQL, or SQL in general, is great for transactional data, maintaining state about a database. BigQuery is really great for asking questions about large data sets, right? So it's really great as an analysis tool. It's not designed to be a relational database. It's designed for aggregate queries, asking questions, and dealing with data sizes that are massive, that a SQL database just can't handle very well.
Yeah, and I mean, typically you actually denormalize your data for BigQuery just to get that additional performance gained by not having to scan over multiple tables.
It seems like it leads it well into the next question, which is a very similar question. So the question
sorry, one second, but just wanted to address with MySQL that usually you can use these technologies together. So don't think of it as you have to use one or the other. You really think about using them together, and we have a lot of our customers that dump data out of relational databases into BigQuery for analysis.
Right. So let's take a look at the next question. So the next question is just what Ryan was talking about. Can this sit on top of a MySQL database, and can it replace Lucene for querying? So yes, I've used all these technologies together too. So just as Ryan said, typically in a workflow like this where you're using a MySQL database for things like transactional data, and the kind of things you would normally use a SQL-style database for, you would actually export the data into cloud storage and then ingest that into BigQuery. And sometimes this does take a denormalization step, since BigQuery is oftentimes used for large tables rather than relational table design. But basically, you can use them together. So I would take the data out of MySQL and place it into BigQuery for some of these kind of analysis tools. Now, you mentioned Lucene in this question. Lucene is great for things like searching. It's kind of a search tool. And and App Engine has a full text search API for stuff like that. However, you can use BigQuery for some types of search. One thing that it may be difficult for a full text type search is that we have a 64 kilobit record size. So if you have unlimited text, it's hard to dump megabytes into a single BigQuery record. You can break that text up and have an index sort of type situation in BigQuery. But in general, for a full text search kind of application, I might use App Engine's full text search API. BigQuery is great for things like word counts, right? So things like we have a Wikipedia data set where we have revision history. You could do word counts, word statistics, things like that. That would be a great use case for BigQuery because the data in those situations can get very big if you have a lot of text.
So one thing that we're actually powerful, though, in terms of text searching with BigQuery is our regular expressions capability. So although the row size is a little limited, for the text that you do have stored in those rows, you can run regular expressions on it. And you might think, running regular expressions on hundreds of millions or billions of rows would take a long time. But, BigQuery can actually do that in seconds simply because it's distributed to such a wide number of machines. So try out the regular expression search if you're trying to just search, for instance, titles or abstracts or something like that, as opposed to a full document. BigQuery might be good for some of those use cases.
And we have that public data set in BigQuery now, the Ngrams data set. So we have a selection of Ngrams from the Google Books project, where you can see how we've used Ngram data as sort of a way you can do searches. You can search for phrases and search for particular Ngrams. And so check out how we're doing that. I guess the short answer is you can use all these. These are all complementary technologies, and in a real big data workflow, you can use them all together.
And there's actually one other thing we want to talk with you about is just kind of share a little bit with you guys about what we've been up to over the last week. So we've been having a lot of fun over the last week, pulling late nights. I think it was up to 2 or 3 a.m. a couple times, playing with some of the Wikipedia data that we found. We actually found at dumps.wikimedia.org, they actually have the number of page views by hour for every page in Wikipedia going back for about 5 years, I believe. And so we've been crunching along this data and trying to use some of the other Google Cloud technologies, just to get familiar with some of the other Google Cloud technologies like the Pipelines API on App Engine. Michael, do you want to talk a little more about that?
Yeah, sure. So we're building a complete pipeline. We're extracting the data from the Wikipedia dumps page. We're transforming it into CSV data, into Google Cloud Storage, and we're ingesting that into Google BigQuery using 100% Google Cloud Platform technologies, basically App Engine and the Pipelines API to build the workflow. So for each step, we have a Pipelines API class that we're using to build this workflow.
Yeah, and I think it's 2 terabytes of raw source data. That's actually gzipped data. We haven't uncompressed all of it, but I'm guessing from what we've seen somewhere between 6 and 10 terabytes of uncompressed data. So it's a pretty fantastic size of data, and it's really great to play around with that data in BigQuery. And like I said, we've been having a lot of fun pulling a lot of late nights.
It's been fun, and eventually we'll share the code from some of these projects so you can actually check out what we're doing yourself.
And I don't think we actually have any more questions from the audience on our moderator. So we'll wrap it up for this week, but wanted to thank you all for joining us. And invite you to come out to some of the upcoming community events that we're doing, whether you're in the Bay Area, whether you're in Boston or New York or London. We may actually even be out to Sydney in the fall. So let us know where you're going to be and join us where we're going to be. We'd love to talk with you about the big data challenges that you're having and see which of the Google Cloud Platform technologies are a good fit. Love the question.
Don't forget to add the Google Cloud Platform Developers page to your circle so you can find out about all these upcoming events.
Great. That's it for the Michael and Ryan show.
We'll see you
Take
again.
care.